All right, guys, we're back again. Here is 1.3 Limits of Rational Equations, Part 1. If you take a look at this, the limit as x approaches positive infinity of 1 over x, and you replace all your x's with positive infinity, 1 over a super large number, imagine infinity to be 1,000. 1 over 1,000, it's pretty small. Or 1 over a million, or 1 over 10 trillion. What is that number approaching? It may never get there, but as the bottom number gets bigger and bigger, it's getting closer and closer to zero. Even if you throw negative infinity, 1 over negative a billion is negative, but super duper close to zero. So that goes to zero as well. With that in mind, it works just like finding horizontal asymptotes. Finding horizontal asymptotes falls into one of three categories. When the degree on the bottom is greater than the degree on the top, which is really x to the 0th, then the horizontal asymptote is y equals 0. That's what the value of y approaches but never gets to as x approaches positive or negative infinity, by definition of the asymptote. So solving these problems, these end behavior problems for these rational equations, it works just like finding the horizontal asymptotes. Here's the technique that our book wants you to learn when finding the limits of these rational equations. Our book wants us to divide each and every term by the highest power of x in this entire problem. The highest power of x in this problem is x to the first. So the limit as x approaches positive infinity, dividing everything through by x to the first. 3 over x to the first, 4x over x to the first, and negative 1 over x to the first. So far, so good. Does anybody have any questions on that? Then they'll notice that this cancels. It's gone. And then reapply the limit. With this philosophy in mind, 1 over x goes to 0 as x goes to infinity. What do you think 3 over a really large number goes to? That's right, it goes to 0. So instead of saying equals 0, the notation that we like to use is it slashes out and that part goes to 0. That 4 remains. That 1 over x, as we apply the limit, negative 1 over x, negative 1 over huge, that portion of the problem goes to 0. So our final answer, 0 over 4, which is 0. Again, using the asymptote method to find the limit as these things approach positive or negative infinity works every time, and it's much quicker. Okay, so the limit, 0, same as the horizontal asymptote. Here's what I like to call the Smith method on these problems. So if the limit as x approaches positive infinity on polynomials only behaves like the highest power of x, then the top behaves just like that. The bottom behaves just like that. That other stuff's inconsequential. Shove in infinity now. So what's 3 divided by 4 times infinity? 0. Okay? The Smith method is going to work here in a moment with different questions. As the degree of difficulty increases, the Smith method is one of the shortest methods. Let's try this one. Using the asymptote technique, the degree on the bottom is 2. That's the biggest exponent. The degree on the top is 1. Since the degree on the bottom is greater than the degree of the top, this has a horizontal asymptote at 0. 0. Remember, This only applies if the limits go to positive or negative infinity. If it goes to like 7, then you just shove in 7. So this technique of the horizontal asymptote, it's end behavior type techniques. Now let's do the way the book intends us to do this problem. The book intends us to divide every term by the highest power of x. So as your limits go to infinity on a rational equation, what's the highest power of x in this problem? X squared. So we're going to take that 5x and divide it by x squared. We're going to take that x squared and divide it by x squared. We're going to take that negative 4 and divide it by x squared. We're going to take everything and divide it by x squared. Some things cancel. This cancels with one of those. Both of these cancel and you're left with 1 over 1. And nothing cancels here. Now it's time to apply the limit. 5 divided by negative infinity, that part goes to 0. That part, no place to put the x. It goes to 1. And that part goes to 0. Negative 4 divided by infinity squared, that goes to 0 rapidly. So it is 0 divided by 1 minus 0. So 0 divided by 1 is 0. So far, so good? Now let's do the Smith method on this. The limit as x approaches negative infinity of 5x over x squared minus 4. The top individually as a polynomial, that goes to 5x. It only behaves like 5x. The bottom polynomial only behaves like the x squared. Now, one of these x's cancels with one of these x's, and reapply the limit. In this method, we're canceling out an even number of x's, so we don't have to really worry about the nature of the final answer, especially when it's 0, whether it's positive or negative 0. And that's a quick look at part 1 of rational equations.